All right, let's take a look at 8.2. We have interval estimation of a mean when we have a known sigma, which is our standard deviation. All right, so for a confidence level, so this is just a given confidence level interval, for a population mean is found with this formula here. So it's X bar, so your mean, plus or minus your Z value times the standard deviation of your sample. And then this is just reminding you that the standard deviation of your sample is the standard deviation of the population over the square root of the sample size. Margin of error. So there's that word again. What is it? It is the maximum error of an estimate is the quantity subtracted from and added to the statistic to obtain the confidence interval for the parameter. Okay, so what is the margin of error that is within an acceptable value? Okay, so what you're seeing right now in the news with some things, some of the recounts is that if the margin of error, so states have laws, like if the margin of error is below, or sorry, above 1% or above 0.5%, then there's mandatory recounts. That's what you're seeing there. So let's look through an example of how to work this. Okay, so we have here, we have a sample size of 25. The mean price of a book is 145, and we know that the population's standard deviation is known to be $35. All right, so find a point estimate for the mean the mean of the population. What is the margin of error for this example? And construct a 95% confidence interval for the population mean. Okay, so the point estimate is going to be the mean plus or minus the standard deviation. So let's go ahead and, sorry, not the standard deviation, the margin of error. So the point estimate is going to be given by the mean, okay, plus or minus E for margin of error. Okay, so to find A, we have to actually find B first, and then we do our confidence interval. All right, so margin of error is given by the Z value times the standard deviation of the sample. So let's go ahead and find the standard deviation of the sample. So let's see here. The standard deviation of our sample will be given by the standard deviation of the population, which is 35, over the square root of our sample size, 25. So that's 35 divided by 5. That should give us 7. All right, so to find the margin of error, we need the Z value, okay, plus or minus, or sorry, times standard deviation. So the Z value, oh, we need to go back down here to find the confidence interval. Okay, so 95%. So that means that our Z, we go back to the chart, is 1.96 for that 95%. So this should have probably been A, B, C like that, sorry. All right, so our E is going to be our Z value, 1.96, times our standard deviation of our sample, 7. So that's going to give us 13.72. All right, and then we want to find the point estimate, which is going to be, so that's going to be margin of error. This is for B. Okay, then our point estimate is going to be the mean, which is 145. So X bar is equal to the mean. So it's going to be 145 plus or minus 1372. All right, so let's see, 145 minus 1372, 131.28, 145 plus 1372, 158.72. Okay, so our point estimate is that The mean price of books here is going to be between $131.28 and $158.72. That's for A. All right, and then for C, the 95% confidence interval is the same here. So you would just say, I am 95% confident. Okay, that the true population mean price of a book is between this point estimate here, 131.28 to 158.72. All right. Oh, I skipped ahead here. So let's take a look at this. So here's the steps to finding the confidence interval. So verify the necessary conditions have been satisfied. Is it a random sample? It doesn't tell us. Okay, so we're going to assume it is and go forward. Find the critical value Z that corresponds to the confidence level. So for 95%, that was 1.96. Evaluate the margin of error, which we got to be 1372, so it was 1.96 times the standard deviation, 35 over square root of 25, and that gave us the 1372. Then we are going to find the values of the confidence interval limits, which were 145 plus or minus 1372. And then we have here, interpret the results. So I am 95% confident that the true population mean price is between, and then we have 131.28 and 158.72 based on our sample data. Okay, so that's the 5 steps to finding the confidence interval for part C there. And you can do this in your calculator. Okay, so here's your steps for doing this in your calculator. So let's do this for this one here, or the one we just did. So go to, in your calculator, where it says stat. Okay, so this button right here is stat. And then highlight where it says test. So just use the arrow to go over to test. You want the test that says Z interval, not Z test. So down here for me is number 7. Okay, hit enter. You want stats, not data. So scroll over to where it says stats, hit enter. And then you're going to enter the values. So the standard deviation was 35, X bar 145. The sample size was 25. Then scroll down to put your confidence level in, which for 95% is 0.95, and then hit calculate. And then you get those values there, does it for you. Okay, if you missed that, we're going to do the same thing again for example 2. All right, so for the same data, we're going to do a 90% confidence interval. All right, so our Z value for 90%, if you go back to that chart, on the last page, it was 1.645. Okay, we want to find the margin of error. So the margin of error is going to be our Z value times the standard deviation of the population over the square root of the sample size. So this time it's 1.645 times the, let's see here, standard deviation is 35, Sample size is still 25. Okay, so that is 35 divided by the square root of 25 is 7. So 1.645 times 7, 11.515. Okay, now using the margin of error, construct the confidence interval. So that's going to be x bar 145 plus or minus 11.515. So I'm doing this by hand first, and then I'm going to put it in my calculator. So 145 minus 11.515 and plus. So 133.49, 156.51. Okay, now let's go ahead and do this in our calculator again. So stat, so this button here where it says stat, then scroll over to where it says test. So I'm going to go to the right, 2 of them. And then I want number 7 where it says Z interval. So yours hopefully is 7. If not, find where it says Z interval. Z interval. Enter. Make sure stats is highlighted. If data is highlighted, just scroll over and then click enter. And scroll down. Your standard deviation of your population is 35. Your X bar, so your mean, 145. Sample size is still 25. Your confidence level now is 90%, so you need to put 0.90. Then scroll down, calculate. So 133.49, 156.51. Okay, and then this little paragraph here is just telling here. So this means we're 90% confident that the true mean price of all such textbooks is between these two numbers. Okay, so it is not guaranteed that the actual population mean is in this interval. If you look at every sample of 25, find the mean and create a 90% confidence interval around it, okay, the population mean will be in the confidence interval 90% of the time. Okay, consequently for 10%, it will not be in there, all right? So 25's small sample size. So if I did this with 100 different samples of 25, 90% of the time they would be in here. Okay, 10% of the time they would not. All right, let's see here. Okay, so just a little bit more here. Now this is just going backwards to say, all right, that sample size in the previous question was really small. So what is the sample size that I need in order to make sure that I have a good confidence level and a small margin of error, or I have a certain margin of error that I want to be within? Okay, so here is the formula for the sample size. Okay, so sample size is going to be the z-value squared times the standard deviation squared over the margin of error squared. So let's do an example. So we have a market researcher wants to find a 95% confidence interval. So that's the first piece of information we need. Around the mean for the amount of money a single person spends at a theme park in one day. It is known from past research that the standard deviation of the amounts of money spent by a single person in one day at the theme park is $11. So that's your standard deviation, $11. How large of a sample should the researcher use to ensure the estimate for the mean will be within $2 of the true population mean? So the estimate for the mean is within $2. Okay, so what that means is that you have a standard deviation of 11. E is 2. So you don't have to actually calculate the margin of error here. It is giving it to you. You want your margin of error to be within $2. So that is your E. Your Z value for a 95% confidence level, 1.96. Okay, so if we plug this into the formula, you have 1.96 squared times 11 squared over 2 squared. So let's see here. 1.96 squared times 11 squared, and then divided by 2 squared, which is 4. So 116.21. which we need to infer then that the sample size must be 117. We are always going to round up so that we have a large enough sample size. If we had 116, it wouldn't be enough. Okay, because we need that 0.21 to be within that margin. Okay, so you're always rounding up here. Even if it's 116.005, okay, you're going to round up. All right, so for example 4, if we look at the previous example, what sample size would be required if the market researcher wanted to ensure the estimate for the mean will be within $1 of the true population mean? So your margin of error is changing from $2 to $1. So everything in the top remains the same. So 1.96 squared times 11 squared, your margin of error is now 1 squared. So 1.96 squared, well, it's actually just going to be that there, but do this times 11 squared divided by 1 squared, which is 1, 464.83, which would round up to 465. So the conclusion, to shrink the margin of error without decreasing the confidence level, you increase the sample size. Okay, so what that says is as your sample size increases, so as n, your sample size increases, okay, the width of the confidence interval decreases. Okay, allowing for a more accurate estimate without decreasing the confidence level. Okay, otherwise, the only way to shrink the width of the confidence interval is to decrease the level of confidence. Not desirable. You always want to have the highest level of confidence that is possible for your research.